Good morning all. I Salim, Assistant Professor, Kite Group of Institutions, presenting you ADC and DAC. ADC stands for Analog to Digital Conversion and DAC stands for Digital to Analog Converter. ADC converts analog signal into digital signal and DAC converts digital signal into analog signal. We use generally these ADC and DAC in electronic equipments. Since most real world signals are analog, these two converting interfaces are necessary to allow digital electronic equipment to process the analog signals. Analog to digital converter samples the analog signal on each falling or rising edge of a sample clock. In each cycle, the ADC gets of the analog signal, measures and converts into digital value. The ADC converts the output data into a series of digital values by approximating the signal with fixed precision. Here is our first slide. ADC again stands for analog to digital converter. DAC stands for digital to analog converter. ADC and DAC are essential part of our life, and by some or other way we are using in our day-to-day life. Here are the example of ADC. We have analog signal, like I am communicating with you, like I am generating a sound which is a analog signal. ADC convert it to digital signal like this, and here is the digital signal in which, like at that time I am using my mic to create a sound. My ADC will convert this sound into a digital signal, and when we use loudspeaker, like you use loudspeaker or your headphones, then this digital signal is converted into analog signal or sound signal. Most of the naturally occurring signals are analog in nature. Analog signals are susceptible to noise and difficult to store and process. Digital domains have advantage of it is easy to store and process these signals. So we generally process all the signals or all the information using digital domain. That's why for storage and processing, signals are converted into digital form and it is retrieved using DAC. Steps involved for the analog to digital conversion means steps involved in ADC process, analog to digital conversion process. First sampling, then quantization, then encoding. Some important parameters of ADC and DAC are: while designing these converters we have to choose these parameters like resolution, reference voltage, conversion, settling time, gain, offset error, non-linearity, accuracy, total harmonic distortion. Here are some types of ADC and DAC. First, ADC, flash type ADC, dual slope ADC, successive approximation type ADC, sigma delta ADC. And DACs are binary weighted resistor type DAC, R2R ladder type DAC. This is all about DAC and ADC. In this, while writing your exam, you have to take example of any one, like successive approximation in ADC and R2R in DAC. Please drive a expression for this. Thank you.